This is lesson 312, Angles and Polygons, part 1. Oh, I can't find my little, there it is. The objectives of this lesson is to determine whether a polygon is convex or concave, and to find the sum of measures of interior and exterior angles of a convex polygon. Some of our key terms in this lesson will be the interior angle of a polygon, convex polygon, concave polygon, and then just polygons. Some of these we're already familiar with. We've studied them in previous lessons. And concave I had talked to you about one time in CC, so they're not going to be completely new. Polygon angles. A little note that we'll need to remember is that exterior angles lie outside the polygon and are formed by one side of the polygon and by extending another side. And what they're talking about right here is a side of this, looks like a hexagon, and they've extended it. See how this arrow goes right here, and they've extended it. So it created this exterior angle right here, angle 1, which is an exterior angle. They also extended this top side, and that angle is angle 4, and it also is an exterior angle. And then 2 and 3 are interior angles. And what we're going to do now is we're going to try to figure out how many interior angles each polygon has and how many exterior angles. Let me get my pen going here. And we can see that a triangle, of course, has 3 sides, and it has 3 interior angles. And if we look at the number of exterior angles, it goes 1, 2, 3. Now we could have more exterior angles, but we usually go with what you see in this picture right here. If I extended this line, I would have 4. If I extended this line, there would be 5. If I extended this line, there would be 6. So in total there's 6, but we usually only extend the line one way, not both ways. So there's going to be 3 exterior angles. Now with the quadrilateral, we look and there's 4 sides. There's 4 exterior angles. There's 1, 2, 3, 4 interior angles. And with the pentagon, see, if you extend each side just like this, you can see 1, 2, 3, 4, 5 exterior, got 1, 2, 3, 4, 5 interior. I'm hoping you're seeing a bit of a pattern here. Same with the hexagon. Now that I bet you see the pattern, there's going to be 6 interior angles, there's going to be 6 exterior angles. And of course you can always check by just extending the sides like that. And there you go. Oh, look, they did do the exterior angles. I better go back, and I was working on the lesson for exterior angles, and you'll see when we get to that lesson. Let me just double each of these. When we're actually working with the exterior angles, we don't double them up like that. But if I was to come along to the square, there's 1, 2, 3, 4. Okay, there's 5, 6, 7, 8. So there's 8 total angles. Anyway, you could do that for each one of these to figure it out. And here's 12 total. But like I said, we only use half of them. We only extend it one time. But anyway, there's the correct table. But you can see the pattern. Your number of interior angles is going to equal number of sides and we're going to call the number of sides n. N equals number of sides. So this is n and this matches n, but in the exterior angles you're going to have 2 times n, 2 times the number of sides for exterior angles. Okay, convex and concave, and this kind of gives you an idea of how to work those. This is the main thing I want you to get out of this. This is how we tell if they're convex or concave. There's no points of the lines are in the interior. See how all the lines go right over the edge, and you don't see any of the lines inside the interior. So that means it's convex. Okay, when you're looking at the concave, and when I draw the lines, see how they're taking it across the edge of this side and the edge of this side. Well, then I have all these points that are inside the polygon. So that's what makes it concave. My trick for seeing a concave is it caved in on a side, like it's caved in right there, and it's caved in right here. That's how I tell if it's concave or not, but the line trick will always work. Now we're going to also talk about the sum of measures of interior angles. It says polygons with more than 3 sides have diagonals, and the polygons below show all the possible diagonals drawn from one vertex. That's key here. You can only draw it from one vertex. So I'm going to start here, and I'm going to draw one diagonal. In this pentagon, they started right here, and they drew this diagonal, then they drew this diagonal. Okay, and it's important that you know you're only going from one side. In this hexagon, this looks like, they all look like clams. When you get to a hexagon, they all look like clams. There you go. That's how it works. And if you look, we know that the measure of the sum of the angles of a triangle are always going to equal 180. So the sum of interior angles for this quadrilateral is going to equal 360. And all I did was take, there's 2 triangles times 180, and that equals 360. And it's going to work for each one. So you got 180, 180, 180, 3 times 180, and then whatever that equals. Have no idea what 3 times 18 is. 45 plus 3 be 48. 480 degrees. Okay, just wanted to show you how that was going to work, because we're going to complete a chart. With a triangle, you have 3 sides, and the number of triangles in a triangle is 1. And so the sum of the angle measures, because remember, if you got a triangle, the sum of the angle measures is 180. Now with the quadrilateral, I just showed you on the other page, we have two triangles. Well, here I can say 2 times 180. That's going to give me 360. With the pentagon, I had 3 triangles, so I have 3 times 180, and I believe that came out to be 480 degrees. Let's look at a hexagon. I can pop right back. Hexagon has 1, 2, 3. Oh, wrong one. 1, 2, 3, 4. Hexagon has 4 triangles. So I can come over here and say 4 times 180. And I don't know this one. 18 times 4. So that's 720 degrees. Now, I hope you're seeing a pattern here. Each of these is increasing by 1. My number of sides is always increasing by 1. Well, if you look, well, that one doesn't count. my number of triangles is also increasing by 1. So I'm going to say plus 1 means a heptagon has 5 triangles, plus 1, an octagon has 6 triangles. So you say 5 times 180. That's going to give me 900 degrees. And then I'm going to say 6 times 180. That's going to give me 1080 degrees. Now that's the sum of the interior angles. Interior angles. So if I had a 20gon, I'm going to let n right here equal the number of sides. Okay? And look here. Each one of these says minus 2. Says I say 3 minus 2, I'm going to get 1. 4 minus 2, I'm going to get 2. 5 minus 2, I'm going to get 3. 6 minus 2, I'm going to get 4. So see how that works consistently? 7 minus 2, I'm going to get 5. 8 minus 2, I'm going to get 6. So to find the number of triangles, I can take the number of sides minus 2. And then, if you look right here, this is the number of sides. No, it's not. Sorry about that. It's the number of triangles. Okay, if you look in this last column, I'm always multiplying everything by 180. And then this number right here always represents my number of triangles. Well, I can figure out my number of triangles by saying n minus 2. So if I had a 20-sided, or a 20gon, is what we call it, and I wanted to figure out the sum of its interior angles, I would just say 180, 20 minus 2, which equals 180 times 18. So that's going to be 18 times 180. That would be, the sum of those angles would be 3,240 degrees. Okay, for each polygon, determine whether it's convex or concave, and if it's concave, explain why. Well, this is just a square, and if you look, it's not caving in anywhere. And if I took and I drew a line, it's not very straight. Okay, but I'm drawing a line right there. There's no points of that line that lie in the interior. So it's going to be convex. Now on this one, if I drew a line, I wish this would let me draw a line. Nope, it's not letting me draw a line anywhere. Wish it would. Anyway, I could go, let me see something over here. If I went on this and I drew a segment, oh look, and it showed up right there. Awesome, awesome, awesome. It's not quite the line I would want it to look like, but it'll work. So if I drew a segment right here, you get to see it. And let me do another one. I'm going to do one right here. That one's a little off. There we go. Draw a shape right here, or a line segment, and then I'm going to do another one. Well, this is cool. I just taught myself something right in the middle of a recording. I taught myself a new trick. Oh, that one's off just a little bit. Let me fix it. There we go. So if you look, all those segments, none of them that I drew actually have points that are on the interior of the polygon. So this is going to be convex as well. Now let's look at this next one. Oh, I'm seeing some trickery here. Let's see, how was I doing that? Okay, went to shapes and I said insert. So let's look right here. And let me do another one just to be on the safe side. There we go. That one's a little off. Let me fix it. I think that's probably about as close as, there we go. So you can see these two blue segments go right through the polygon. So that means it's going to be concave because points, oops, lie inside polygon. And so if they were asking you to explain why it's concave, you could have those lines on there and say that the points lie inside. That's all they want you to do. Okay, this says for each type of polygon, determine the following: the number of sides, the number of non-overlapping triangular regions that would be formed by all the diagonals from a single vertex. In other words, how many triangles does it have inside it? And the sum of the measures of the interior angles. So we know a pentagon has 5 sides, and I also know that if I was to go in and draw, which I'm going to try, well, I can't draw right quick. I can't be as fancy with that as I was that last one. Pentagon has 3. You can always go back and look at the table that we did, and I can roughly draw a pentagon here. And then if I drew from one vertex, you can see the 3 triangles. And if I did 180, 180, you could see that it's 3 times 180. But remember, our formula that we figured out said I can take 180 n minus 2, right? So if it has 5 sides, that means 180 times 3, and so there we go, 540 degrees. And here's the official answer. See how they use the formula? They got 540 degrees. Oh, and look, they didn't even have to draw. They said the number of triangles is the number of sides minus 2. We'll use that next time for a heptagon. So here, heptagon, hept means 7. So 7 sides. B, remember, I'm going to take n minus 2. That will give me the number of triangles, so I'm going to have 7 minus 2, which equals 5 triangles. And then C says, what's the sum of the measures of the interior angles? I'm going to have 180, n minus 2. N is 7, so I have 180 times 5. So 180 times 5 gives me 900. 900 degrees is the sum of the interior angles of a heptagon. I wanted to go back and look at this table. Not that one. Oh, it doesn't tell me. Okay. there's the check. 7 sides. 5 is the number of triangles in there. 900 is the sum of the interior angles. Now, use your answers from problem 6 through 10, which is the ones that we just did, to explain how you would think the interior angle sum formula, this capital I is for sum of the interior angles. Let me write that up here because I don't remember them telling you that. Sum of interior angles, and later on we'll see a little I, which is measure of interior angle, and the little e is a measure of exterior angles. Oop, I ran out of space. There we go. So anyway, they want you to explain how it's derived. Well, we've already done that in the previous table, but I wanted you to see it in words. It says each time the number of sides increases by 1, the number of triangles increases by 1. And so the number of triangles is consistently 2 fewer than the number of sides. The interior angles of a polygon consist of the angles of the interior triangles. So I can take 180 multiplied by n minus 2. I think the table is a lot easier to understand than the verbal. Okay, this is telling us to find x in each figure, and do not assume that side lengths and angles are drawn to scale. Only information that's explicitly given or marked can be assumed, and I've kind of beat that in your heads in the last few videos, but please don't forget it. Okay, so I've got to figure out first how many sides. There's 1, 2, 3, 4, 5. Okay, so it's a pentagon. And to figure out how many, I don't need to figure out how many triangles, I just got to use my formula, silly girl. That's going to give me the sum of all the interior angles. Remember the big I. So I'm going to have 180, 5 minus 2, which equals 180 times 3. So 180 times 3 was 540. Okay, so now I know the sum of all the interior angles. Well, I know the measure of all of these angles right here. All I got to find is x. So watch what I'm going to do here. X is going to equal 540 minus 94 plus 102 plus 94 plus 158. So in my calculator, I always do things separate. It helps me not make many mistakes. So I'm adding all these guys up. So I'm going to get 540 minus 448, which equals 92. So x up here equals 92 degrees. So you've always got to figure out the sum first. Sum of interior angles. And then you got to come down here and do this part. You've got to take the 540, or the sum of the interior angles, and subtract the measure of the angles you do know. And here's the official key answer. Let's look at this one. It's going to work the same way. Let me figure out how many sides I have. 2, 3, 4, 5, 6. So it's a hexagon. So I take, oh my goodness, my brain keeps going blank. It's too late. So I'm going to say 180, 6 minus 2, so that's 180 times 4, which equals 720 degrees. That's the sum of all the angles. And then I'm going to come down here. I'm going to say x equals 720 minus, then I got to add all these guys up. Okay, let me put those in my calculator right quick. Well, you know what? I'm going to take a shortcut to save time on this video. And it doesn't tell me. So 720 minus... Those add up to be 578. So x is going to equal 142 degrees. There you go. Let you kind of process that for a minute. Oh, I must have did something wrong. I was looking at the wrong slide is what I was doing. I hate it when that happens. How about that? I was looking at the right slide, but that'll teach me to try to take a shortcut. Because that's what happens when you take shortcuts. You end up making silly little mistakes. So this should be 587. So this right here would be 133. I still did the same. I did all the concept and everything correctly. I just looked at the wrong slide and got the wrong total for the interior angles. So there you go. That's what the key said. That was the right answer. Okay, let's look at this one. This is our last example. Let's see what we got going on here. 2, 3, 4, 5. Oh, this is a hexagon as well. So I'm going to have 180 n minus 6. Excuse me, n minus 2. So I've got 180, 6 minus 2, so 180 times 4. You'd think I'd have these memorized by now. That was 720. So I come down here, say x equals 720 minus 129 plus 150 plus 86 plus 123. Oh, don't forget this guy right here. That's 90 degrees. So 720 minus, let's see if I can get it right this time. 611. So x equals 109 degrees. Alright, let's see what the official answer is. I did it again, looking at the wrong slide. No, I wasn't looking at the wrong slide. This is the correct answer right here. And that just told me right there I'm not taking any more shortcuts. Okay. This one, also a hexagon. So n minus 2, so that's going to be 180 times 4, which gives me 720. See, you get them memorized after a while. And so I'm going to say x, and then I say 135 plus 132 plus 126 plus 105 plus 113. Oh, I ran out of room. There we go. So x equals 720 minus, and I'm keying them all in this time, 135 plus 132 plus 126 plus 105 plus 113. That one equals 611. So x is going to equal 109 degrees. See there? I didn't take any shortcuts and I got it correct, so don't be taking shortcuts. I just proved to you twice that's not good. Summarize this lesson: all polygons, not just triangles, have interior and exterior angles. Polygons are classified as either convex or concave. And then the formula for finding the sum of the interior angles is 180 multiplied by the difference of n and 2. After you get finished watching this video, you need to go through and read lesson 312 in the LMS. Also read 85 through 88 in the reference guide. Work on problems 2 through 20 even. They're not very hard. And then contact me or attend TOGA if you have any problems with completing the problems in the problem set, because we want you to make good grades on the quizzes. That's going to be it for this lesson 312, and thanks for listening.